Hi and welcome to the latest webinar from Innova Systems. We're going to be looking at an introduction to sheet metal design in SolidWorks. My name is Aprigliano. So let's just get straight on with it. Okay, so we have a satellite receiver, and using the sheet metal tools I'm going to create the sheet metal cover for this. We're going to design the cover in the context of the assembly, so we'll see a little bit on in context assembly modelling as well. Okay, so the first thing I have to do here is insert a brand new component. Okay, now when you do this, the first click is quite important because it will place the front plane of your new component on the face or the plane that you select in the assembly. So I'm going to place mine on here. Okay, it will also open up a sketch for us on that face. So all our sketch tools are now available to use. We're going to design half the cover and then mirror the body across to complete it. So let's go ahead and do that. Okay, I'm just going to sketch a rectangle, turn these lines into construction, and then determine a 1 mm offset on these edges. We'll also have a solid line along the bottom which just extends 30 mm from the edge. Okay, so that's the basic profile I want, but if we look underneath, there's a form in the base plate, and I want this flange to follow that form. So the way I'm going to do that is right click on one of those edges, select the tangency, and then just simply convert those edges onto my sketch plane. I'll then just trim away that small overlap. Okay, so my first sketch is done. We'll now exit the sketch and take that sketch and turn it into a piece of sheet metal. So we go to our sheet metal tab, and we're going to start off with the base flange tab tool. Okay, so immediately as I click that, you see a preview of the base flange, and this is very much like the extrude property manager. You can send it in two directions, and you can determine end conditions as well. So in this instance, I'm going to go up to vertex, and the vertex I'm going to go up to is just that vertex there. Okay, now within sheet metal parameters, we can define the thickness of sheet that we want to use and the default bend radius with it. So I'm going to go for 1 mm with a 0.5 internal radius. If we go normal to the face, you can see the preview there in the sketch, and I can send our thickness of sheet directly above or below that line. With regard to bend allowance, you have several choices in here. You have K factor, bend allowance, bend deduction, or bend calculation. K factor will work out the size of the flattened sheet based on the neutral line. So we're going to use that one. We're going to set the ratio 2.5. We're going to set the auto relief to rectangular, yet we could specify tear or ob round. We'll have a look at that when we see it in the model. Okay, so everything looks good there. I'll just press OK to complete that feature. Okay, so in the part in my tree, that's actually generated 3 features for us. It's generated a sheet metal feature, which consists of all our default bend radiuses, reliefs, bend allowances. We have our base flange, which consists of our sketch and all the base and all the flanges that it's created. And our flat pattern comes in suppressed. And if we unsuppress that, the sheet will actually flatten live on the screen for us. Okay, now if we look at the underside of this, you can see that we've got an interference. So we're just going to remove that interference now, just with a simple cut. And I'm just going to ensure that the cut extends past that curved flange. Okay, the next thing we're going to look at here is a tool called the miter flange. Again, you'll find this on the sheet metal toolbar. We can select it and then select the edge that we want the flange to run along. So in this case, it's this edge here. And we're just going to zoom in on that corner. Okay, so with the miter flange, you draw the cross-sectional profile of it. And one of the nice things about the miter flange tool is that you can draw multiple bends with it. So if I add 2 lines, for instance, it will create 2 bends, as you can see there. Okay, so at the moment, we're currently using the default bend radius. We can specify the flange position as being inside, outside, or with the bend outside. In this instance, we're going to go material outside. We can also select multiple edges. So you can see that as I do that, in the preview, it automatically miters the corner for us. So it's a very powerful tool. Also, when we have multiple edges selected, this rip gap becomes available to us. And as I start changing that, you can see it changes the gap in this area here. We can also determine a start and end offset. So if I set that start offset to 4, for instance, it will just create a gap there, an offset of 4 before that flange starts. Okay, so now that that's done, we'll just complete the feature. And if we zoom in on this corner here, you can see that it's put our rectangular relief in. Now, just to show you the difference between the relief types, if we go back into our sheet metal feature, tear will actually tear the sheet. And an knob round will just round that relief off, like so. Okay, another tool that we use commonly in sheet metal is the edge flange. Very simple to use. Just select it from the menu and then simply select an edge and you can drag a flange off in either direction. The angle of the flange can be determined within the property manager. And if you have lots of complex angles, a handy thing to use is perpendicular or parallel to face. So you basically select a face in this box here and then define whether it should be parallel or perpendicular to that face. Flange length can be determined here. So again, we have various end conditions. I'm just going to fill in a value of 12. And that 12 dimension can either be taken from the outer virtual sharp, the inner virtual sharp, or from the tangent bend. So that's new to 2012. And what that basically means is that, let's say you had an acute angle that you was folding to. The dimension that you give it will be taken from the tangency of the bend. So imagine measuring it with a vernier, for instance. Okay, so in this instance, we're going to go from the outer virtual sharp. You can also determine the position of that flange, material inside, outside, bend outside, from the virtual sharp or from the tangency of the bend. Okay, so in this instance, I'm going to go material outside. And I'm also going to select a second edge. So again, this is a very powerful tool. You can see it automatically miters that corner for us, which is great. we'll just press OK to complete that feature. Okay, so you can see what we've got. What we want to do now is actually mirror that whole body across. So we'll just spin it round and zoom in. Okay, so we mirror this as pretty much as we would within a normal part. Click on the mirror tool. One of my tips with working with sheet metal is because you have a lot of small faces, very thin faces, you might find that you're constantly zooming in and out to make selections. I like to use the magnifying glass a lot with sheet metal. That will just allow me to zoom in on a particular area of the model rather than zooming in on the whole lot. Okay, so from there I can pick the face and then just simply select a body to mirror. And there we have it. The next thing I want to do here is I want to create a flange that sits inside that slot that we see there, which will eventually be fixed through this hole here. So with this we use an edge flange, but you can see that when we select edge flange, it selects the whole length of the edge, and that's not what we want. So we can just simply edit the flange profile, and that takes us into a 2D sketch, and we can start manipulating these sketches to be where we want. So all we'll do is zoom in and I'll create some relationships. Like so. Okay, now with this flange, at the moment we've got a closed profile. So it is important that you have a closed profile when you're working with this. But you can have a multiple contour profile as well. So for instance here I can select the edge of that hole and convert it to entities. So we actually design this with the hole in it. Now if we go back, we have our choice of flange position, so it can sit inside, outside, bend outside, and so on. None of those give us exactly what we want. So to get it to sit all the way inside, we can use this offset. And that will just allow us to drag this out by a distance or an end condition. And the nice thing about this is it can go either way. So what I want to do is specify a distance of 1, but have that sit inside, like so. Press OK, and you can see that it's done a really good job of that. And again, we can see the reliefs, and you can see that the hole that has been placed in there as well. Okay, so because we've designed this in context, we've created relationships between the cover and the base assembly, such that if I was to go in and actually update this base assembly to reference the large configuration, you can see that our cover will update with it. So you're building in some nice intelligence into the model there. Okay, now currently this part, this cover part is internal. It has no external file at the moment. So what we're going to do is we're going to save this externally. First thing we do here is rename the part. We'll call it cover. And then just simply right click on it and then save the part in an external file. And I'll just save it at the same path as the assembly. Okay, now you might have noticed that the square brackets from around the cover in the feature tree have disappeared. That just indicates now that this part is saved externally. We can open this part in its own window and start to make some changes to it here. So the first thing we're going to look at is the form tools. So we have a Form Tools folder in our design library, and you can just choose to drag and drop a form tool in. You'll get a preview of it as you drag and drop it. You can flip its direction as you're dropping it or after the event. So as I drop it, that will launch the Property Manager down the left-hand side. Now, this has had a revamp in 2012, so you'll see now we can really easily change the angle of the form tool, or we can flip the tool so it goes in either direction. We now have configuration support for form tools, so if you've created multiple configurations of a form tool, you can just pick which one you want from this drop down list. And we also now have the ability to link to the form tool, such that if you make any changes to your form tool, they will propagate through to anywhere where that's used if you want them to. This is now very much like the Hole Wizard Property Manager, where you select the type and then you define the position. So what happens here is it automatically selects the point tool for you, and if you want to add multiple instances of this form tool, you just simply add more points. Okay, I'm just going to dimension this. Like so. And then we'll hit the green tick to complete the feature. Another nice sheet metal tool that we have is the hem tool. So with this tool, we can select edges where we want to apply the hem. You have a choice of several different types of hem. You can have closed, open, teardrop, or rolled. In this instance, we're going to go for closed. We'll come in and select an edge, and there we can see the preview of it, and we'll just set the size of that to 12mm. Okay, now with the hem you can set the material inside or outside, and if you don't want it to run the whole length of the edge, you can edit the hem width and then just start dragging that sketch about. Okay, now I want to add multiple edges with this hem, so we'll use our G key again just to aid us in selecting our edges. Press OK to complete the feature. Okay. On our hem we'll add another form tool, so I've got another one here, and we'll just drag and drop that on like so. And I just want one instance of this for the moment, and we'll just dimension it from this edge to here at, let's say, 15mm, and then 6mm from that back edge. Okay, now I actually want multiple instances of that hem, and the reason that I didn't do it in the Form Tool Property Manager itself is just to illustrate the point that you can actually pattern these form tools. Like so. And it's worth pointing out that we can also mirror them as well. Okay, so we'll take the pattern and the indented grip, and we'll mirror those about our right plane. Okay, so that's our part almost completed. There's a few other little bits and pieces I want to do here. One of the first things I'm going to do here actually is add some fillets. So everyone's probably used the fillets that you'll find on the features toolbar. You may not have come across the break corner trim tool on the sheet metal toolbar. That will just basically allow you to do a simple fillet or chamfer. So what's the point of using it? Well, basically it's specifically for sheet metal parts, and it just makes the selection so much easier. If we was to use a normal fillet tool to remove some of the sharp corners, we'd have to zoom in on each edge and select that small edge there, often selecting through geometry. With the break corner tool, you just specify what you want, the size of the rad or chamfer, and then start picking faces. And because it's sheet metal, it automatically knows where to chamfer or fillet. So the selection process is much simpler there. Okay, now the flat pattern at the moment is suppressed, and to unsuppress it you just simply click on the flatten button, and we should very soon see a flat pattern of that. There it is. And what we want to do now is look at how we can reference that flat pattern within a drawing. Okay, so I'm going to just draw your attention to the configuration manager, and within here at the moment we just have our one default configuration. Now if I go to File and then Make Drawing from Part, we'll pick our border. You'll notice that in the view palette we have all our standard views, but we also have a flat pattern view. Let's just drag that in and we'll change the scale to, let's say, 1:1. Okay, so how does it get that flat pattern view? Well, what happens if we go back to the model is that a new configuration is automatically generated as soon as you use this part in a drawing. It creates a flat pattern configuration. And if we just split this in two, what happens is in the default configuration, that feature remains suppressed. In the flat pattern configuration, it's unsuppressed. Okay, now it's quite important that once you've created your drawings, etc., that you keep the default in the folded state and the flattened in the flattened state. Okay, so back to the drawing now. What can we do with these drawings? Well, as you would expect, we can dimension them. We can dimension to bend lines, to model edges, to form edges, etc., etc. We can also make these drawings look a bit nicer and a bit easier to read by harnessing some of the additional options for sheet metal within our document properties. So to do that, we just go into Options, Document Properties, Sheet Metal. And within here, for instance, we can change the bend line colour in the up direction to, let's say, blue, in the down direction to red. We'll change the form features to an orange, bend lines for hems to, let's say, a yellow. You can also determine where your bend notes are. They can be above, below, or with the leader. Okay, so by doing that, the person that's actually making the part has a sort of a better visual guide of how it actually is made. Now from here, a lot of people that use laser cutters and punch tools will tend to save that out as a DXF. There's a couple of things that can go wrong when you're doing that. One of the things is the scale. Let's say we put this on a scale of 1 to 5. People get confused when they're saving as DXF what scale they are saving out as. The other thing that people have to do is remove quite a lot of the detail. So perhaps they don't want the bend lines, the bend notes, the border, the form tools, that sort of thing. A lot of the time they just want the outside profile. So in my opinion, it tends to be better to save the out as a DXF directly from the model itself. It's very simple to do. It's just a case of right-clicking on the model. Doesn't matter if it's in the folded or flattened state, and then go and export to DXF or DWG. At this stage, we give it a name, and we just have to ensure that we select sheet metal. Now, it gives us some options here of exactly what we want to export. So we can export the geometry, so we want to do that. We can include things like bend lines or exclude them, sketches, library features, form tools. It's up to you what you want to include and exclude. In this instance, I'm just interested in the geometry. So I press OK, and that will launch a preview window of exactly how that will save out. So there it is there. Again, the nice thing with this is that you can clean it up prior to actually confirming the save. So let's say, for instance, we are only interested in the outline. We can take that hole and just remove it. Okay, so now we're ready to save it. We can just click on save, and that's done. And it will always save out at a 1:1 scale. Okay, some other nice tools that we can use in sheet metal. One of the things that this isn't sort of necessarily for sheet metal, but just a standard tool that people tend to not use so much, is the fill pattern, and it's quite a powerful tool. You pick a face, select the fill pattern, define your fill boundary, which is a face or a collection of edges or sketch lines. You can define your pattern layout from the options there. I'll skip that and we'll just go to create seed cut. This is where we can use a predefined shape to cut our model. Now we'll go back up. Well, let's in fact just change some of these dimensions. We're just going to set it to have a 6mm spacing, 60° stagger angle, and a margin of 12mm. Now you can see it's really intelligent in as much as that it will actually go around features and try its best to fit those pattern cuts in. Now let's say, for instance, I don't want all of those. I can come down to instances to skip and just remove a couple. And when I'm happy, I can press OK to just complete that feature. Okay, from the design library, I'm also going to just drag in a sketch. And we're just going to place that sketch on the origin with a coincident relation. And add a dimension to constrain it. Okay, now I'm going to use the vent tool to create a vent in this sheet. So again, some of you may not have come across this tool. I'm going to launch it using the command search. So to do this, we just tap S on the keyboard. And if you look at the top right hand corner of the screen, by pressing S, it actually activates the command search. Then from there, if we just type in vent, you can see it finds a tool for us. We can launch a tool directly from there. Or if you want to know where it is for future preference, just click on the glasses and it will place a subtle red arrow next to it. Okay, so we'll go ahead and launch it. First thing it asks us for is the boundary. So we're going to select the outer rectangle of that sketch. It will then ask us to define our ribs. So all we do here is select the internal portion. Let's just change the width of those to 1.5. and we'll also select the spline as well. Okay, so within here you can define the width of the spar and ribs. You can't, with sheet metal, define the thickness because it's sheet metal. It has to be of a uniform thickness throughout. You can define whether you want radiuses. So if we zoom in and just turn on 0.5 mm radiuses, you'll see the preview change, like so. And let's say it's a plastic part, you can add draft to it as well. To complete the feature, we just press OK. So very quickly, we've created our vent. That for me is a very powerful tool. Okay, now if we go back to the model, you can see all of those changes have propagated through. And the last thing we're going to do here is just insert face bezel. So we go to Insert Components, browse to our face bezel, and we'll just insert it. Now just notice within here we have a little star symbol next to our component. That just indicates that it is a smart component and you can bring features through with it. To insert those features, just right click, Insert Smart Features, and then just pick the reference face that you want to apply that to. So we're just going to select the face of the our cover, press OK, and if we isolate our cover, you can see that it's automatically added 3 hole cutouts there. Okay, so that brings us to the end of this demonstration. Just for your reference, we have some future webinars coming up. They're every Thursday at 10 AM. If you've got any questions about what we've just gone through, feel free to get in touch with us via our support address or give us a call. Thank you for watching.